Scenario 2 is where interesting things start to happen. We are now specifying increases in the real accident year loss ratio over time. So for accident years 1 and 2, we are specifying a loss ratio of 60. For accident years 3 and 4, that gets bumped up to 65. And for accident years 5 and 6, that gets bumped up to 70 by the simulation that's generating this data. The result I'm going to explain is this. If the only thing that changes is the real accident year loss ratio, then the paid and reported development methods will work. Let's look at the paid loss data. Accident years 1 and 2 are the same. Then there's a bump in the losses for accident years 3 and 4, which are both the same, and then another bump for accident years 5 and 6. Now, the key question is, how does this affect the LDFs? The answer is that it doesn't, which you might find surprising. The dollar amounts have changed from year to year, but the way they develop has not. If you look down each column in the LDF triangle, the LDFs are all the same. That means making your LDF selections is going to be very simple. Every column has the same numbers. Here are your selections. Here are your CDFs, and here are the resulting ultimates. You can see now from the summary table, which shows your estimate of ultimates side by side with the real accident year loss ratio, and so it's easy to see that your estimates are all 100% accurate. Now, it works exactly the same with the reported loss data. The reported loss data is greater than the dollar amounts are greater than the paid data, of course, and the reported losses develop differently from the paid data, but that's completely irrelevant. The development pattern for the reported data is completely stable, and that means that it will also produce a 100% accurate result, as you can see again from the summary table.